Okay, good evening, students. So, we are continuing with the chapter Chemical Kinetics. We will see further into the chapter the Chemical Kinetics, part of Physical Chemistry, class 12. Okay, so we have discussed how to express the rate of reaction in case of small simple reactions having one reactant and one product, and also the stoichiometric coefficients on the both sides of the equation are same. Our example was yesterday in the previous class example we took this one, right? The stoichiometric coefficient this side is 1, similarly this side the stoichiometric coefficient is 1. So if both sides the stoichiometric coefficient is 1, then the rate of the change of reactant dr minus dr dt is equal to the rate of the change of product. Okay, we have learned this one, that if the stoichiometric coefficient on the both sides are same, then this will be the situation. Now, to understand, we come to a further more complex case. Suppose let us consider this side the stoichiometric coefficients become 2 and this side the stoichiometric coefficient remain 1. Now this is the thing, I have even given a sample problem in this in your assignments. In this case these two things will not be equal, this will be unequal. dr by dt will be not equals to dp by dt. Now why these two will be not equal? This is very much clear by the concept of molecularity, by the concept of moles in your class 11. In class 11 there is a chapter called moles, right? So in this class 11 chapter called moles, you have already known that why this is. Let me explain you in brief. See what happens here. In this reaction, actually try to understand very clearly. Actually, two atoms of R element. This must be element or a molecule, right? This must be atom or a molecule. So, two molecules of R, say R is a molecule, okay? Two molecules of R combine to make one molecule of P, okay? Two molecules of R combine to make one molecule of P. Two molecules of R are combining to make one molecule of P. Now, if initially we have taken two molecules of R and zero molecule of P, right? We have taken two molecules of R, we have taken zero molecules of P. Now after the reaction, the number of molecules of R will be 0 and the number of molecules of P will be 1. Because by the stoichiometric coefficient, by the coefficient ratio, by the ratio relationship of 2:1, we see that if two molecules of R destroy, they are making one molecule of P. Okay, there is nothing to explain here. It is very simple, right? It is very simple. Like hydrogen plus oxygen will give you water. Now for balancing this one, we can give here 2, we can give here 2. Now what we can say, that two molecules of hydrogen and one molecule of oxygen combine to give two molecule of water, right? Two molecule of hydrogen and one molecule of oxygen combine to give two molecule of water. Same way here, two molecules of R combine to give one molecule of P. So initially we have taken two molecule of R and product is not yet formed, and ultimately finally after the reaction there will be zero molecules of R and one molecule of P. One molecule of P. Now what is the rate of change of R? What is the rate of change of R? Minus of final minus initial. What? -2 by time taken, suppose t. T. Okay? And what is the rate of change of product? Final minus initial by T? 1. So in this case, this will be 2 by T. In this case, this will be 1 by T. Right? So see, these two are not equal. This is very simple thing. These two will not be equal. This is basically 2 times of the rate of change of product. The rate of the change of reactant is 2 times the rate of the change of product. Because when 2 molecules of R are combining, 1 molecule of P is being formed. When 2 molecules of R are combining, 1 molecule of P is formed. That's why the rate of change of R will be double than the rate of change of P, which is very much evident by these two. If we multiply this with 2, then it will become equal. Okay? So this is the analysis. That's why these two will not be equal. Okay? But we have to know one thing, that the rate of reaction is always unique. Rate of reaction is a unique quantity. One second. Rate of reaction is a unique quantity. So if this and this are not equal, if this and this are not equal to each other, then we cannot call these two as the rate of reaction. Because if this value is 2 and this value is 1, then we cannot say the rate of reaction will be 2 and 1. Rate of reaction have to be unique, have to have one value. So there is a confusion. एक प्रॉब्लम आता है कि हम इन दोनों में से किसको रेट ऑफ रिएक्शन बोले. तो इसीलिए मैं बोल रहा था कि ये दोनों इक्वल नहीं होगा, तो ये कॉम्प्लेक्स रिएक्शन, इसमें प्रॉब्लम है. तो हम क्या करेंगे, यहाँ पे स्टोइचियोमेट्री का प्रयोग करेंगे. देखो, इन दोनों को इक्वल करेंगे. कैसे इक्वल करेंगे? माइनस डी आर बाई डी टी, इसको इसके स्टोइचियोमेट्रिक कोएफिशिएंट 2 से डिवाइड करेंगे, और dp बाई डी टी, इसका स्टोइचियोमेट्रिक कोएफिशिएंट 1 है, तो 1 से डिवाइड कर दिया. अब ये दोनों इक्वल है. और अगर ये दोनों इक्वल हो चुका है, अब इसको हम ओवरऑल रेट ऑफ रिएक्शन बोल सकते हैं. अब हम इसको ओवरऑल इस रिएक्शन का ओवरऑल रेट हम इन दोनों को बोल सकते हैं. बोथ द वैल्यूज आर सेम. नाउ सी फ्रॉम दिस, इफ यू take this to this side, it is very much evident from the fact that dr by dt is 2 times dp by dt, which means the rate of change of the concentration of reactant is 2 times the rate of the change of concentration of product, which we have got from here. Analysis, simple analysis. If you divide this by 2, then it becomes 2 by d. That means the rate of the change of reactants is double than the rate of the change of product. इतना कुछ समझने की कोई जरूरत नहीं है, इतना कुछ पता होने की जरूरत नहीं है. एग्जाम के टाइम पे हम इतना कुछ नहीं कर सकते. तो बस हमें सिंपल सा फंडा याद रखना है कि जब हम रेट ऑफ द रिएक्शन लिखेंगे ऐसे रिएक्शन के टाइम पे, है ना, जहां पे स्टोइचियोमेट्रिक कोएफिशिएंट सेम नहीं है, तो वहां पे हम हर एक टर्म को 1/2 से डिवाइड करेंगे. बट वन मोर थिंग, अगर आपको पूछे कि व्हाट इज द रेट ऑफ द चेंज ऑफ द कंसंट्रेशन ऑफ रिएक्टेंट, है ना, तो यही होगा. इसमें 1/2 से डिवाइड, इसमें 2 से डिवाइड मत करिए. बट इफ दे आस्क रेट ऑफ रिएक्शन, देन यू हैव टू डिवाइड बाय 2. इफ दे आस्क रेट ऑफ रिएक्शन, देन यू हैव टू डिवाइड बाय 2. Okay, you understood this one, you have noted down this one. Now let me just give a small summary. Okay, give a small summary with the help of a good example. Now see, let us consider a multimolecular reactions. Let us consider a multimolecular reaction. Now see, what will be this multimolecular reaction like? 2a plus b 2c plus 3d. Suppose this is a multimolecular reaction. Now, what is the rate of change of concentration of A, it will be minus dA dt. This will be clear. Next, if there is rate of change of concentration of B, this will be minus dB by dt. Same way, if they ask rate of change of concentration of C, this is product, so no negative sign, this will be dC by dt. Same way, if they ask what is the rate of change of concentration of D, it will be ultimately dB by dt. Okay, clear? But none of the things are same. None of these four quantities are same. Why they are not same? Because the stoichiometric coefficients are different. Stoichiometric coefficients are different. Now see, minus dA by dt, dB by dt, dC by dt, minus, and sorry, this is dd na, dd by dt. So none of the quantities are same. So how will you determine the rate of reaction? These all are the rate of reaction of individual elements in the reaction. But now we are speaking about the overall rate of reaction. Okay? See, now we will divide this one by 2. Stoichiometric coefficient is 1. So we will divide by 1. We will divide this one by 2. We will divide this one by 3. And now this all the quantities are equal. And now we can call this as overall rate of reaction. So this way we can write the overall rate of reaction. This much for today. Contemplate of these things. We will meet soon in the next lecture. Thank you. Stay safe. Jai Hind.